Assalamualaikum and hi everyone. In this video, we will present two topics, which is pulse modulation and multiplexing. First topic will be pulse modulation. As what we know today is the technology is rapidly advancing. Thus, the telecommunication components has used digital signals in operation. So we need to convert the information signal into digital form because digital signal transmission requires a signal which is in the term of binary or pulse signals in discrete form. And there is four types of pulse modulation, which the first one is pulse amplitude modulation PAM, pulse width modulation PWM, pulse position modulation PPM, and the last one is pulse chord modulation PCM. Usually, in a pulse modulation, we have three steps to do, which is sampling, quantization, and coding. In this slide, I will present about the sampling theorem. In the sampling theorem, we have three types of sampling, which is natural sampling, ideal sampling, and flat top sampling. Other than that, we have also two types of theorem that exist in the sampling theorem, which the first one is Nicias theorem that states Fs is larger or equals to 2 Fm, and the second one is Shannon theorem that states Fs is equal to 2 Fm. After the sampling process, we will do this quantization, quantizer or amplitude changer. Quantization is a process of estimating the sampled amplitude into a value for coding. There is three terms that are usually used in the quantization process, which the first one is quantization level that can be calculated using a formula of L equals to 2 to the power of n, depends on the number of the binary bits, which is n, used to represent each sample. The second one is quantization interval, magnitude difference between quantization level that also can be calculated using a formula of Qi equals to V peak to peak over L. And the last one is quantization value, the middle voltage for each quantization level. There are two types of quantization, which is the first one is uniform quantization and ununiform quantization. Uniform quantization is a process with uniform and fixed quantization interval and spacing, while non-uniform quantization is a process in which the quantization interval is not fixed and not equal. The last process that involved is coding. Binary 1 and 0 in PCM signal can be represented by several formats known as a line coding. So we have several types of consideration to take in line coding format, which the first one is transmission voltage and levels, duty cycle, bandwidth, synchronization, error detection, and correction. We have to take all of these consideration in order for us to follow the format of the line coding. And after this, my fellow friends will present more about the pulse modulation and multiplexing.
So now I will be talking about different forms of signal modulation. First, let's discuss pulse width modulation. Pulse width modulation is a form of signal modulation where the width of carrier pulse is varied according to the sample message signal. The higher the amplitude of the sample message signal, the wider the pulse width. Pulse width modulation has several advantages such as being cost-effective, having minimal voice interference, and achieving high efficiency with up to 90% efficiency in some systems. However, it also has its drawbacks. The circuit designed for PWM can be quite complex, and it may produce voltage spikes and radio frequency interference. Besides, pulse width modulation is widely used in applications such as encoding data for efficient transmission in audio and video systems, controlling power to adjust motor speed and light brightness, and converting analog signal to digital signal for processing. Next is pulse position modulation. It is a modulation technique where the amplitude and the width of pulse are kept constant, but their position change based on the amplitude of the reference message signal. This method has some advantages, including easy separation of signal and noise, high power efficiency compared to other pulse modulation techniques, and simple communication between the transmitter and receiver. On the downside, PPM requires a large bandwidth than PAM, involves a more complex system, and demands precise synchronization between the transmitter and receiver to ensure a proper signal detection. PM has some applications in control systems like RFID and contactless cards, radio control systems such as drones, remote control cars, and the analog to digital signal conversion. Lastly is pulse chord modulation. It is a method where an analog signal is represented as a digital chord. It involves a series of steps to achieve this transformation. PCM consists of four main steps to digitize an analog signal. First is sampling based on the Nyquist-Shannon theorem to prevent information loss. Second, the quantization level. Third, the quantization interval. And finally, the quantization value. Next, TCM offers advantages such as higher transmitter efficiency and greater immunity to noise. However, it also has its challenges, including the need for more bandwidth compared to analog systems and the complexity of the circuit involved. PCM is widely used in telephone systems like landline, long-distance communication systems, including satellite and space communications, and encryption protocols such as AES-256 for secure data transmission.
Now, I'm going to present about multiplexing. Multiplexing is a process of transmitting two or more signals simultaneously over a shared medium. The possible ways to link multiple pairs of devices are many to one and one to many. The objective of multiplexing is to increase the capacity of transmission channel.
There are several types of multiplexing used in telecommunications. The first one is frequency division multiplexing, which different signals use unique frequency bands within the available bandwidth, just like the radio station. The second is time division multiplexing, which multiple signals share the same frequency channel and each signal takes turns in the time slot. The third one is wavelength division multiplexing, which the light beams of different colors transmit data in fiber optics. It usually used in the high-speed internet. Next is chord division multiplexing, which encoded signals travel together and decoded at the receiver. The last one is space division multiplexing, which the data flows through multiple physical channels simultaneously, just like the multiple cables. It can increase the capacity in optical fiber system. Let's look at the advantages of multiplexing. The first one is efficient bandwidth usage. Multiplexing can maximize the capacity of communication channels. The second one is cost-effective. It can reduce the need for separate physical channels. And third one is scalability. Multiplexing supports multiple data types transmission simultaneously, just like voice, video, and also internet. However, here are the challenges that we need to address. The first one is complexity, which the multiplexing system requires advanced equipment for encoding and decoding. The second one is interference, which the signals can cross-talk and it will lead to degraded performance.
Now, I'm going to talk about the application of multiplexing in real life. First of all, multiplexing is applied in telephone networks. For example, time division multiplexing (TDM) enables multiple voice calls to share the same transmission line by assigning each call to a specific time slot. Next, frequency division multiplexing (FDM) also applied in traditional analog telephone systems to allow simultaneous voice communication over a single cable. Next, multiplexing also been applied in television broadcasting. For example, frequency division multiplexing (FDM) combines multiple channels into a single frequency spectrum for over-the-air broadcasting. In addition, digital multiplexing also applied in digital video broadcasting (DVB) to combine video, audio, and metadata streams into a single digital signal. Thirdly, multiplexing also applied in satellite communication. For example, frequency division multiplexing (FDM) and time division multiplexing (TDM) were used. Both of these multiplexing enables multiple television, radio, and data streams to be sent to and from satellites over shared frequency bands. In addition, chord division multiplexing (CDM) also applied in satellite communication to manage multiple signals across a single frequency spectrum. And finally, internet and data communication also applied the multiplexing. For example, wavelength division multiplexing (WDM) applied in optical fiber networks to transmit multiple data streams on different light wavelengths, significantly increasing bandwidth.